Sir, how do I model braces that only take tension instead? Or why is STAAD showing compression in my tension only bracing system? Can we use tension only members in direct analysis method? And the other question was, yes, is there a way to deactivate some members only for gravity loads in STAAD? Or why does my STAAD model fail when I use truss members in braces? Can I keep my braces active only for wind or seismic loads? See, if you have ever asked this question, stay tuned, because today I am going to show you a super powerful yet beginner friendly feature, the inactive member command in STAAD.Pro's direct analysis. See, many structural systems like X bracing have members that work only in tension, but instead, if you don't model them carefully, they may show compression forces under gravity loads, leading to wrong results or failed checks. So what is the solution for that? See, to solve this, STAAD lets you deactivate specific members for specific load cases using the inactive member command, and that's a game changer when paired with direct analysis. So let's check this out with the STAAD model with example.
Now to make you understand, here I have considered one direct analysis model. You can observe a brace frame over here, and we'll check out this. Here are the members, and see, in this example model, braces which are mostly tension only members, but what we can do is we can assign them the truss member. Okay, so what I have done is I have specified them as a member truss to all the members. Okay, now we will run the analysis. The model is already ready, but to give you a highlight, I'll run the analysis quickly. Now when the model analysis is done, I'll just show you on the post-processing mode. Here, see, I have considered three cases only: dead load, live load. Then there are two other cases, which is dead load plus lateral load, means wind load from left or right. Alright, I'll just show you the cases as well. Here I have considered three cases. Right, we have run the analysis and we have put some lateral loads over here. Now if I go to the post-processing mode, let's first check only dead load case. Okay, so I'll click on the dead load option over here. Right now we will check out the axial forces here first. So I'll click on the axial force, I'll scale this. Okay, now to give you an idea where is the tension and compression, first of all we will check out the diagrams over here, and in results you can see that compression is indicated with the blue color and tension with the red color. So you can observe over here as these two members are in tension, rest of the members are in compression, right? This is for the first case, that is your gravity load case. Okay, if I check the other two cases, the scenario will be different. Now if I check, see, this is the first case. Now if I see the lateral load case, okay, wind from the left, you can observe that the bracings are also going into a tension, right? Vice versa, this is from left, so when the wind load is acting from the other direction, this bracings are coming in picture, and when the wind is acting from the right side, this bracings will comes in picture. You can check out the loading here to get the idea. Okay, see, right, as the force is applied in this direction, this whole bracing will go in the other direction. If I want to show you the deflection pattern, you can see, right, this is wind from left, from here, so this bracing will go in tension. Similarly in the other direction, when the force is acting in this direction, it will pull it in this direction and this bracing will go in tension. So the same case is happening over here. You can judge it from this axial force diagram. When the wind is acting, this bracings will comes in picture, and for the other case this is coming in picture, right? So you can understand this behavior now. Now what we can do is we can check this member axial forces for each load case. We have checked, right? For gravity load, it doesn't impact But for the lateral load forces, you can see bracings are in compression and tension for the individual load case, right? So what we can do is, for the first case, that is your gravity load, right? So it is just a gravity load, so all braces are usually majorly in compression, right? So what we can do is we can use inactive member for 9 to 14 members in the first case, for the first case, right? Similarly, for the load case 2 and 3, you can include lateral load. Some braces are in tension, right? So we selectively deactivate only those which go into compression using the member level segment. So in that particular, you can use this inactive member command. So specify inactive member, specify the member name, and then the particular load case number, and that's how you can inactivate that. Similarly, so that's the STAAD editor command. So this particular keeps only the tension braces active with respect to the load case. Got it? I am repeating again. See, for the second and third load case, what you can do is, see, some braces are in tension, so we selectively activate only those which go in compression. Okay, so if I show you the second load case, this load case, right? So whichever the bracings in compression, we can deactivate that or inactive that. Similarly, for the other case, it will be different. So case wise, I can use inactive member command in editor, inactive member, then the member number and particular load case. So this keeps only the tension braces active for a particular load cases. Okay, now why this works? See, this approach mimics the real world brace behavior without complex non-linear settings or iterations, and you are letting STAAD handle load specific logic while keeping your model clean and correct.
See, you can even combine this with load combinations or design commands, giving you full flexibility and realistic results. Just remember to always check forces first before applying the inactive member. So if you found this video helpful, like it, subscribe to the channel and comment below if you want the full walkthrough of truss versus tension only modeling or a deep dive on nonlinear analysis in STAAD. I'll see you in the next video. Until then, keep learning, keep sharing, and always remember, don't just learn software, learn concepts. Thank you.